everyone, and welcome back to the Information Bottleneck podcast. And today we have a great guest, Bayan Bruss, a VP at Applied AI at Capital One. Hey, Brian.
Hey, great to be here.
And as always, hi, Alan.
Hi, it's great to be here.
So we came back from all the holidays. So hope you had a really good break and holidays, and you did a lot of fun. Um, s- and today let's start with some recent news or like what is happening in social media and things like that. It looks that everyone are talking about Cloud Code, that everyone are using it, doing amazing thing, right? Like writing games, solving very sophisticated problems with kind of like vibe coding. And it looked that it started since the last model released. What do you think? It's an hype or like this is the AGI?
Is there somewhere in between those two things? No, I think it's
No.
no, I have to pick one polarity. It's either hype or AGI. I think it's an impressive, it's a really impressive capability that, my guess is what happened is that a lot of people had a little bit of extra time over the holidays as their year wound down, and they finally got around to like, hey, let me build that thing I've always wanted to try. Oh, I'm going to do it with Claude Code and see what it does. And lo and behold, they discovered that this is a really powerful, um, tool. Is it AGI? Let's table the conversation of what is AGI and whether we're there yet. But I'm curious to hear from you guys. What do you think? Because have you seen a significant improvement in Claude Code in the last 2 months? And what are the things that you've noticed about that improvement?
Now, I'll point out Ravid actually was using Claude Code before me. He actually has been the one who also got me into Cursor first thing back in mid 2024 or maybe early 2024. So have to give you a lot of credit for being the true early adopter. But I used a lot of Claude Code last month with Opus 4.5. There was a new version update. Both Opus 4.5 comes out, but also a new version update with Claude Code that added a lot of new features. I'm of the opinion that probably the biggest single improvement that made Claude Code better beyond the model improvement was improvements in context compactification and automatic handling of that. I still think it does a pretty poor job relative powerful it is. Like, it's amazing how much it punches above the weight of its 200K context. And I find that especially profound. But I also find that a lot of the value that I get from it comes from babysitting it. And when people who are so-called AGI pilled, what they're not telling you is that they have to do all these things in order to get Claude Code to actually have control. So for example, -- dangerously skip permissions. Oh, but then it won't let you do that in root, so you don't actually have Claude controlling your computer. What do you have to do then? You have to fake it out into believing it's in a sandbox environment with is sandbox equal 1, then Claude, then dangerously skip permissions. That's the AGI pilled version. And that's kind of scary, right? Occasionally, I just want to point out, like, the S in AI stands for security. And the moment that somebody realizes that a prompt injection that sufficiently gets somebody's Claude Code that's searched on the internet for a solution to just RMRF or better yet, upload all their data, to some server somewhere, and all that. Like, I love this stuff, but I also do not like that it is better outside of the a GUI or better outside of an IDE than within it. So yes, you can run Claude Code through the terminal in your IDE, and it even has some integration with it, but it's designed to be ran with either its desktop app or just the CLI independently. And does even have what some people perceive as performance degradation when like combined with the editor, and that concerns me. But yeah, I'm definitely I'll also point out that on the, I think AGI is a low bar. I take the Peter Norvig take, which is that it was hit on day one of ChatGPT coming out, and most humans are really stupid. So an AI model being bad at most things but good at a little is enough for me to think that that's humanish, right? And so I think that this was a profound moment analogous to ChatGPT, specifically for software engineers, where many of them who start using this start getting concerned. I don't know. I was never like super good at writing like very high performant code, very like GPU, like CUDA kernels and stuff. And that's the one thing that I think that, these kind of tools will still struggle with. And that basically just rewards really high IQ people, right? I think. And I'm really scared as like a certified midwit, basically, that tools like this really will automate a lot of my day-to-day work.
Yeah, I don't know. I'm sure that that they will automate some of our work, like most of our work, but I don't think it really matters at the end. Like, of course, I think they really got much better in the last 2 months, especially Claude. Seeing compared to Codex, it's much better. And you can see, like Anto, the thing that like was really amazing for me is like the difference between to use it, doing the with the terminal versus using it with cursor. I'm not sure what is exactly the reason, right? But it's totally different tool. It's totally different model. It looked like in the terminal, it knows how to do this self reflection and to analyze, and like you just need to prompt it, and as you say, to babysit it once in a while. But most of the time, it just get better and better and analyze its own mistakes. But in cursor, it just doesn't work good enough, right? Like it just dump.
Don't you think a lot of that is in the software and systems engineering that's going around the model? And
Yes.
Yeah.
and as good as the models are getting, the products and the features in the products, which are more scaffolding, are the things that are actually advancing quite rapidly, and they're probably advancing with the help of AI coding tools, right? Like they're not just advancing on their own, but they are advancing because somebody is thoughtfully creating and designing products that get better. And even the things you described as like part of the babysitting, I wouldn't be surprised if in very you know very soon in the next version or the version after, many of those things are just baked in to the system so that it feels less and less like babysitting, and it's going to feel more and more like it's just operating on its own.
So on that note, my real world usage experience has a few things around how that babysitting works. So it allows you to, like, even while it's thinking, type in your own like stuff to kind of tell it, oh, change your behavior. You can even stop execution. But certain things they tell you, like, oh, write a Claude.md file that it'll always respect. I have very specific environment stuff, among other things, forcing it to use UV in a specific UV environment. And if it doesn't do that, then my Jupyter network drive gets really messed up, and it can destroy my whole instance because I'm on Jupyter notebooks and have a weird setup. So then it doesn't have the like guarantee to always look at that Claude MD before it takes another action. And so even with all the context compactification, I find if I go deep enough and I'm not using /clear to force clear the context and intervening when it's about to, usually when I have to intervene, it's over some like environment nonsense most of the time like this. And so I will point out that that is still a significant cognitive load, right? And that's where I think the role of software engineers, like you were talking about, I think I can't remember if it was on camera or in the beforehand, about how the role of like people, when imperative programming came out, and interpreted languages, sorry, not imperative, interpreted languages got popular, Python especially. People from the compiled world were upset, and I'm sure that people who wrote assembly were really upset when C and C++ and automatic pointers came out, right? So I yeah, I just want to say that there's still a role for humans, but I want to also mention I watched the computer chess world, when I was a little kid, go through the same exact thing the LLMs did, benchmark cheating and everything with the Rybka chess engine circa 2009, just like Llama 4. It's all, like it echoes. And the time period between when a human could beat the best chess player at 2000 Deep Blue, very famous moment, right? And then the moment where human plus AI was worse than AI alone was, depending on how you calculate it, like 5 to 13 years, but it was definitely by any metric hit in 2013. And with that in mind, I do worry that like the clock is ticking, and I do worry that around 2040s or so, I got to go become a plumber.
I mean,
But
let
this
me
is
let me
like,
ask you: Are there still people playing chess competitively?
yeah.
Yeah, but that's for fun. That's the problem. Like if chess
But
was a, eh,
it was always for fun.
It was always fun.
Like this is the point. But I think like assembly programmers, it's a good example, right? Because like I don't know, I heard someone post that like that LLMs are like kind of like just bad compilers, right? They translate English uh, um to computer. But I think this is the point. Like it's not that like people just stop programming anymore, right? They just move to do other thing, and like move to do more important thing that can bring like I don't know, broader scope, or like make it more complicated or whatever. But it doesn't stop and like, oh, now everyone just went to do something like I don't know, go to the
Well,
beach.
I mean, I think the last, whatever, 75 years, 85 years has been one abstraction after the next as we try to get machines to do more and more, without as much hands-on, right? Like, I'm sure there was a generational divide between the people who had to actually physically build the systems while they were programming it and the people that didn't have to do that, right? And so we're in definitely a transition phase as we do another round of, let's call it abstractification of this broader system. But at each generation, you don't see fewer engineers on the other side. We see way more. So it's like we make it more abstract and then more people do it. And there's always a fallacy of in when you look at the past and you're making predictions that, because that was the way it has happened in the past, we made an abstraction and we got more engineers. But this time will also be true. We'll make an abstraction and we'll get more people who are building software. It's hard to tell. I I would bet on there being more engineers in a decade from now than less if I had to put my money on it.
I agree. I do agree. So there was Andres Karpathy post on Twitter that got a lot of attention about that. He feels that like he's much behind as a programmer, and the profession is like dramatically refactored and change all the time so fast, and it's really hard to keep on track. And I agree, like it's really hard for us that we are doing it every day, and like for other programmers it's hard to keep the fast progress, and to understand how to adjust and how to change our tools, right? Like now with code, you have so many new tools that like I don't know how to use all these tools. We need to learn, right? Um, but for the long term and for the society, or like the general programmers, I think it will be much better and will give us much more tools and options how to make new things.
Can I ask you guys a question? Ri- uh, in Richard Hamming's book, which I think I referenced earlier in a pre-conversation, um, he talks about, in these phases of massive technological transition, the scientist, or the role of a scientist, the best ones focus on their fundamental knowledge of the field and making sure that they really go deep on not necessarily what's the like staying on top of all of the latest and all of the changes, but really understanding the fundamentals. Do you think that still holds, or are we in a place where like even the fundamentals are changing too fast?
So I personally don't think the fundamental change, but I think this is so. It was true all the time that like now if you want to make, I don't know, a new company, probably like you don't need to learn I don't know how like the specific neural network, the specific neurons work on the specific architecture for 99% of the cases, right? But if now you're a student, I think like your best bet is to go to learn linear algebra, right? And it was like that in the last 60 years, right? So there is something like you still like to make an actual work and to make progress, you don't need to fundamental, but they are still the same, and probably it's a very good signal that you can do it, and very good signal for the future. So it depends.
I'm also influenced by people who kind of do philosophy of science. I have not read the work that you've referenced, but the two that I am familiar with are Karl Popper, and I do not remember the name of like his main book. It's like a structure and something in scientific revolutions. I think I have a copy of it. I read
That's
it.
Thomas Tian.
Oh God, yeah. I'm mixing them up. Anyway, that's one of the major ones. But the one that I have read quite a bit and I consider very important to me is called Against Method,
Okay.
outline anarchistic theory of knowledge by Paul is it Feyerabend, and he he just means this more as a like the scientific method as taught in traditional like grade school is as being the rigid way that science is done maybe isn't the right way forward. But I always think of him because he wrote a final book two before he died, where he was basically just saying that it's called Conquest of Abundance. And in Conquest of Abundance, he's basically saying that no matter how big you think any possible domain or problem or even thing or entity or abstraction is, it's bigger than you think. And the only other analogy I can give is there's old like Dharmic, like Buddhist and Hindu fables about like the amount of time, like, the God is living in one equivalent moment is like, take a spoon and imagine how long it would take to like shovel Mount Everest and move it. Like these kind of analogies to try to like jot this into our heads. And so that's, I think, the source of the idea of, okay, we're going to have more engineers and more problems, even with better technology and more abstractions, is like that the universe is very abundant.
Yes, I think that's absolutely right. The Kuhn one you referenced was interesting because I feel like it is a bit where we, having gone to NeurIPS this year and other conference last year, I feel like it's a bit where we are. He talks about paradigm shifts in scientific revolutions, and how when a new paradigm comes along, it kind of has this effect of violently sweeping away all of the dominant theories that predated it, and very quickly. Many people switch over to the new paradigm. Obviously, there are some folks who stay behind and continue arguing for the old systems that they originally believed in. But many people move on. But what ends up happening is like a lot of the fundamental problems get solved up front in the new paradigm because that's kind of the big, large territory that gets staked out in this whole new landscape that you're on. And then very, very quickly, it starts to congeal into what he describes as kind of puzzle solving and problem solving. So people who are making these tiny little tweaks to the broader theory that was proposed to get it to fit the data, to fit the reality a little bit better. And it's remarkable that in 100 years ago would be like a 50-year process, or maybe like a 30-year process between when a new paradigm shifting theory comes out and when you get to like puzzle solving. I feel like we've condensed an entire scientific revolution into like 5 years, which is why it feels so insane to all of us. But I do also feel like we are, at least for now, and entering that phase of the paradigm that's no longer big swaths of territory are being developed for the theory. It's really getting the small pieces to fit into the broader picture.
And a quick eulogy for Stack Overflow and its even lesser known cousin that the machine learning, hopefully, and data science people were going to cross-validated. I remember that place. Yeah, exactly. And They are, I mean, a lot of people agree that that place had problems, especially with moderation. Every, other question shut down as not relevant or duplicate or whatever. But at the same time, I worry so heavily about the ability to reconstruct even getting to the jump off point of like Chat GPT being somewhat crippled if there was an EMP. I guess this is a traditional, opposition to calculators too, but it
Sure.
really feels like in a whole different way we've kind of pulled up the ladder. There's a paper that shows that people, monkey see, monkey does, where they read LLM generated stuff all day and they use it in their human spoken communication. So
Yes.
like it's not X, it's Y, delve, certainly, all these other phrases and ticks and templates become in humanity, basically, in our or not zeitgeist, but our collective way of speaking. So I worry now that in a sense we can't go back in a way that doesn't feel like it was true before. I mean, maybe it was like, oh, people
But
read the Bible and it infected them after the printing press with Gutenberg too. So maybe I'm just much ado about nothing.
also, I will. I'm not sure if you saw it, but there is like a graph that show like the number of questions per month in a Stack Overflow, right? And apparently this time, like I think in the last month, they just went down below their like when they just like I don't know, maybe 10 or 11 years ago, right? Like when they went to IPO. So like you have these, they got to some maximum and then they went down in the last 7 or 8 years. But the interesting thing is that they actually like this I don't know, they reached to the peak much much before ChatGPT.
ChatGPT.
So ChatGPT was like really like the last thing that actually affect them, and the whole I don't know, dynamics of internet and how internet works actually make them went down much before. So I don't think we need to, oh no, ChatGPT just ruined the world and people are not asking questions and
I've had
making,
this.
we,
Yeah, I've noticed this thing about my own behavior as I interact with the internet, is where either I'm curious if you both find this. Either I'm getting an AI summary for something when I want some piece of information, or I'm like using AI to find it, or I'm going to Reddit to see specifically what do people say about this topic. And
agree.
it's not really in between. I want to know that I'm getting like opinions of people, or I want to know, like generally speaking, the like canonical answer that I believe I can get from an AI system. And that's all very, I didn't, I would occasionally go on Reddit for, news and like entertainment purposes like 5 years ago. But now it's like one of the primary places that I go to see what do people think about this topic. And so in some ways it's like making human thought more valuable as it distills more and more human thought.
Yeah, I don't remember who talked about it, but he said that like probably in the near future it will be much more important to have imperfect products or imperfect solutions to show that they are like actually like human generated, right?
That's right.
And like the perfection, and now that everything is just exactly as you can imagine, will be something that, oh no, like why to do it, like LLM is all like doing it, so we will try to push and to make things differently. I think this is I think that like at the end we want to hear something, like if we don't want to go to LLM to hear this general opinion about something, we want to hear real humans and like real problems and imperfect world and imperfect solutions.
I think even if I were offered not even general information, even if I were offered highly curated information to me, that's like some system that fully understood my context and my needs and my desires, and was going to customize exactly the answer to my context and my reality, I still, as a person living in the world and operating in like a broader social system and dynamic, want to know the opinions of other human beings on the topics that I care about. And those opinions can be the same as mine, those opinions can be different from mine. It's not that I'm looking to just get what I want to hear. um, I feel like my own navigation through the world relies on an understanding of like how other people think, as much as it relies on just getting information.
Yeah, I just so for example, when I looked for recipes, I know I want to bake a cake or something like that. So sometimes I went to ChatGPT and ask it, right, and I get very general recipe, and I can adjust it, and it's really easy. Right, but sometimes I must admit that I'm trying to actually like explicitly go to Google and search for a cake, for a chocolate cake. I'm not sure why actually, because I think I want something that like real people actually tried and
Right,
make
exactly.
different, yeah, like make these different I don't know amount of sugar and try it and say, okay, this is good and this is not, and not very general average opinion about everything.
But here's why would you? This is the crux of the question. Like, why is it more important to you to see that a human tried something and what their thinking was about it? Then you could prompt a model and say, "Give me your chain of thought that tells me why you think I should add this amount of sugar." But like, what is the like? Is it the fact that the human engaged in it and you know that they have the firsthand experience is like an epistemology problem, or is it just that you trust a human being more than you trust a model?
So I think it's the first one. I think that like someone actually did it and tried, because the LLM didn't do it, right? It just like collect information from different sources and try to merge them. But if two people just say, "Oh, this is a good cake," right? For different, I don't know, amount of sugar, he doesn't have like besides this besides just aggregate this information, it doesn't have any way to know that this is good or not, right? Um, like again, of course, you can prompt it and to say like, "Look, be more suggest me more things that like based on this chef or something like that." You can do it, but I think in general, it's much easier to just to ask humans.
That's like that's like a what I would call social intelligence. It's like knowing that okay, I wanna like believe that this person knows what they're talking about because they have this kind of experience. I might trust them a little bit more if they're a chef, or I might if they're cooking a specific type of cuisine, I might trust them a little bit more if like that's the culture they're from and that's what they grew up eating. So therefore, they should know what the flavors really taste like, and we kind of have this like broader social understanding of the information that we're receiving and the information we're giving, and we use that to like make decisions very intuitively. Um, and yeah, it's not that I don't feel like it's possible for AI systems to get there, but it certainly feels lacking at the moment.
Yeah, and when you talk about looking for like proof of humanity, going on Reddit is astroturfed, and it has and most other websites where people are known to go to try to look for assistance, especially with like buying products. It's really obvious in some cases if you've like researched products when that's the case. And so, I a long time ago realized, at least in tech scene, I needed to go to Hacker News. And there are other various enthusiast communities. Often they are very unwelcoming. Like, for example, there's one web forum around menswear clothing called something Fedora in the name. It's like a forum around like high-end men's clothing, and very, very unwelcoming community there, as is all good, old school web forums should be, right? But I in our work on the anti-slop sampler, we've also seen one of the obvious ticks for somebody using an LLM, at least to rewrite at minimum and possibly generate everything, is fancy quotes that can't be easily typed, right? The EM dash that people can't easily type, overuse of semicolons as well. And I see it all the time, even from powerful people now, even in some cases from posts where I do think it was a human behind it, because the one thing that LLMs or AI systems are still pretty bad at right now is complicated image and video. Like if there's many objects on a table and I ask it to list out like all 37 objects in their position, humans are way better than the best AI models at those kinds of gritty, intricate tasks. Um, But yeah, that's often, what I'm looking for too is proof of humanity and proof of human intentionality and effort put into solving some kind of problem. And showing that proof is fascinating to. I'll just say one last thing. I have always been a crypto skeptic. I don't hold crypto. I hold a tiny bit of crypto backed securities, but I always thought that the principles behind crypto, like write only encryption, distributed ledger, would be great for proof of originality, right? And so, like, the point of NFTs in my mind was not to buy and sell them, but for an artist to patent their style and be like, if somebody copied me, that's bogus. Not even like they shouldn't, but if you want to go pay somebody, you should go pay the originator of something, right? And so I was fascinated that it never took off for that one use case, right? But I worry that this is something where we need to find ways to still at the honor people who originate, especially good ideas,
Yes.
in concept.
Okay, I think maybe we are ready to deep dive to banking and why we actually care about banking. So uh, as all of you know, Bayan is a VP at Capital One. It's a bank. They have a lot of banking data and they are doing a lot of things about it. So maybe you want to tell us why we should care about banks and banking
Sure,
data.
sure. Well, let me just start by explaining a bit about who we are and what we do. You probably, if you're in North America, you've seen one of our many ads. If you've watched any sporting event, you probably have seen more ads than you want. And when I go to AI conferences, we usually have a booth and presenting some of our research, and most people assume that we're a quantitative trading company at the conferences, but we're actually a more traditional bank. We provide things like credit cards, bank accounts, auto loans, across a very large percentage of the American population. And broadly speaking, this is what's called consumer finance, which would be different from other types of finance, those that are kind of involved in trading or hedge funds or corporate finance. There's so many different types of finance, and broadly speaking, finance is the kind of the set of services and businesses built around money as a broad technology that we've come up with as a species. And why should we care about it? I mean, I think it's uh, personally, I find it endlessly fascinating, particularly consumer finance, but other types of finance as well. It's kind of the intersection of technology and the behavioral sciences, things like psychology and behavioral economics, and it requires a deep understanding of people, because at the end of the day, money is distinctively a human thing. It does not exist in other species. It is something that we have come up with. Um, it is something that we don't really agree on what it is. Like, if you ask historians, they'll say it's one thing. If you ask economists, they'll say it's something else. If you ask anthropologists, they'll say it's something completely different. And then even in day-to-day life, like the way, Alan, you think about money, the way, Ravid, you think about money, the way I think about it, is going to be very different between all of us. And yet everybody uses it. Everybody interacts with it. It's it may be like the organizing thing that makes all of modern world possible, is this piece of technology. It's maybe the original emergent technology, before AI. And because it's this thing that like is so complex and maybe so unknowable, it creates all kinds of interesting problems from a machine learning and an AI perspective in terms of how do we interact with it, how do we understand it, how do we build systems, which is speaks to what my team is focused on, which is how do we build systems that could make autonomous financial decisions, that's at the far destination. But that's where we're heading to.
Well, somebody with credit cards, Capital One, I think, is one of the people that offers those, right? You
Yes.
mentioned consumer finance, and so I guess I have so many questions, especially around finance questions that are maybe slightly less about AI. I guess, and maybe tie it in as much as you want into AI, but do you think markets are efficient? I feel like that's like a very opinionated philosophical one to start with that helps kind of explain all of how you think about money from answering it.
Well, I think you should start with, an explanation of what an efficient market is, um, which is
I get.
yeah.
Yeah, keep.
No, no, please go ahead.
Oh, I was just gonna mean like do markets mostly have like near perfect information? Like I think that's what people mean with efficiency, right? Like do they take information in and quickly disseminate it and make highly optimal decisions given that?
Right. Will the price that the market set be the optimal price, and will that happen as fast as it possibly can? I think in some situations, yes. In many situations, yes, that's true. Um, I think there are also a lot of situations. So, like, this is where it gets interesting. I, you know, I'm a I'm more on the like behavioral economist side of things than the like classical economist. So that's not my training, just like my personal belief system in this field would be more in tune with Daniel Kahneman and others like that. Um, there's this kind of classical economics view that this market is this kind of uh, entity that lives alone and independent from the participants in the market, and that it has a will of its own and it can regulate itself, and it can kind of exist. So, many of the people who talk about markets the way they do is the same way that people talk about AI. It's like this intelligence that can do all things, and that if we just get out of the way, it'll solve all of the world's problems. But I firmly believe that markets are, the emergent property of many, many different individuals and humans, and whatever the collective uh, biases and limitations of those people that participate in the market get reflected and amplified by the market, um, which includes things like speculative bubbles, which includes things like financial crashes, and all the different ways that humans can lead themselves and others astray. The market's not above and independent of those. The market is a determinant of them.
So let's go a step back and let's ask like, okay, what types of like problems you are trying to solve? Like what types of data do you have? Like why
Yeah.
you care about this data?
So I think when we think about this destination of, how could an AI system participate in a financial decision, we have to think about like what is a financial decision. There's a lot of different kinds of financial decisions. Most people would be familiar with many of them. Like an investment is a financial decision, right? A loan is a financial decision. Um, uh, you know, Exchanging something can often be a financial decision. And so, what is the like crux of a financial decision is it is a belief. Really, what it boils down to is it's a belief about something that's going to happen in the future. So you take like the very simple example of an investment. Um, if there's different, obviously there's different kinds of investments, but like the more classical example would be you buy a stock in a company. The reason why you buy a stock in a company is because you believe that sometime in the future the value of that company, because they're more productive or it's more efficient, or it's doing something in a new way, will go up at that point in the future. And so if you buy it now at a certain price, you will make money because the value will go up. So what are the components of the decision that you just made in that context? So there's one is like an understanding of everything you know about that company, an understanding of everything you know about the kind of market and the economy that that company operates within, and then a prediction about the future. And then within that context, you're not just making a prediction about the future. You need to ask, okay, uh, what decision do I make? Is the price today higher than what I think it will be in the future? Or is it lower than I think? And then you finally make the decision, which is, do I buy it at the price that I can get it at today? So the final decision is, a purchase in this case. Another case might be, if you're lending someone money, the decision is, how much do I lend to them? And in that case, the things that you need to take as inputs are everything you know about the customer, again, everything you know about the broader economy, and then what you think that's going to tell you about the future. and then you make your final decision. So, broadly speaking, the problem boils down to these like 3 or 4 discrete components. One is, understanding or perception of the financial ecosystem. 2 is some kind of prediction, which is really just a statement of belief. It's a statement of your belief about what's going to happen in the future. And then 3 is, the actual action that you take conditioned on that belief. And so in order to get AI systems to be able to do that entire thing end to end, you need to make it much better at all 3 of those things. And so a lot of the work of the last 5-6 years in financial services and on my team has been on the first one, which is, can we just get it to understand money? Can we get it to just understand how people behave with regards to money? And can we use that information? So can we solve the perception problem and use that to get it to state beliefs about the future in a way that's really accurate? And
Do you
a
think
lot of, yeah, go ahead.
I will try to like to push back a bit, because like do you think we actually need to understand them separately? Because the whole shift of let's say deep learning is moving from feature learning, right, to like predefined features to something that learn end to end. So basically, probably people will tell you why you need to know like what are the beliefs of the society, or like specific people or something like that. Just learn it end to end. Do you think there is something fundamental that requires you to separate these problems?
No, I don't think it's fundamental that requires you to separate them. And actually, much of our work has been building a unified system that does all of this. I separate it because when you work on these systems, in the same way that like if you've worked on computer vision, right, like you first have your work on the encoder, and then you have your work on the action models that take the encoder inputs and use that to make the predictions. And so that's kind of how people think about it in a lot of autonomous systems. But no, I think the goal is to have an end-to-end system. I don't think you can get away from belief or some kind of prediction about the future. Because at the end of the day, what action would you take if you didn't have some stated belief about the future? Like, how could you possibly decide to give somebody a loan if you didn't have some expectation, some quantification of your expectation that they'll pay you back? Now, that can be one
And
system that does both of those things, but you still need to state your belief.
Now, related to that, how do you handle things like so-called protected variables or categories? Because I know things like zip codes can't be used because they approximate, all the other demographic information that oftentimes regulators do not want you using it's directly, in making credit decisions.
Yeah, it's a great question. There are a lot of laws that govern particularly financial services around what kinds of data we can use for our models. And there's good reason, historical reason for why those regulations exist. And I think it broadly uh, protects the American consumer. Many countries don't have those protections. Actually, the United States is fairly unique in that. And the way we typically look at that problem is we try to remove those categories altogether. So we look at everything that we put into these models and we say, okay, let's not use any proxy variables. That, of course, only gets you so far, right? There's plenty of things in the data that we have. And so, Ravid, you asked what kind of data we have, right? We have billions of financial transactions. Every credit card swiped for hundreds of millions of American consumers. We have, everything you do on our mobile app. We have all of the payments that you've made. We have a lot of different kinds of financial data. And we try to use that to inform these systems as much as we can. And as you move to more, unified end-to-end learning systems where you're not manipulating the data as much and you're not doing the feature engineering, you're kind of left with this question of like, well, what is it learning? How do we guarantee there's two parts of this. One is what Alan said, which is like, how do you guarantee that your model hasn't learned something that you didn't want it to learn? And it's actually one way is to like think about that from the perspective of these protected attributes, but the other way to think about it is, learning that somebody's age correlates with their likelihood to pay you back for a loan. May not be, gets to like this question of like causality. That's not actually a cause of your ability to pay somebody back. That's just like an ephemera of the data. And so you really want to make sure that the things you're learning are clear and directly related to things like the person's ability to pay you back, things like their willingness to pay you back.
Well, I'm not sure that I understand. Let's take age, for example. So, like, I don't know, for me, right, I think that, like, if I would build a system that has age, right, so probably it's like a good estimator, right? It's a good indicator for someone that will pay me back. So, do you want to use
Why?
it or like you don't want? Why? Because like probably there is a good correlation, right?
Between what though? Like, what is the correlation that you're trying? This is what the point is. Like, what is the thing that you think it's telling you?
I don't know. Yeah, even like he's like I don't know, like he's I don't know. He's too smart to give the money to the bank and not to
Okay, so
to,
like you could say that age correlates strongly with wealth, right? Like people tend to make more money as
for
they get older.
example.
Therefore, if you have more money, you're more likely to pay someone back if they take out a loan. The argument that I would make there is you should just be using wealth instead of using age as a proxy for the thing that you think it's modeling. Is like just get the thing that you want.
But it may be that you don't have access to it, right? Like, I don't know. For example, you don't have access to his previous failure to pay, right? It can be that like he moved to another bank. I don't know how does it work, but like you have some information that you don't have access, or like it's too complicated to understand
Yes.
it. So this may be a good proxy, though.
Yeah. Well, in that case, we're explicitly prohibited from using it as a proxy.
Yeah, for sure.
I would say that's the like constraint of the work that we do is that we have to have clear we have to have a clear line of sight to how that piece of information should be related to the things that we care about, because that both protects us and protects our customers. Also, if the like economic landscape shifts, then you know that the model is still fundamentally built on some real world principles and laws. But there's an inherent tension, right? What I'm describing, because 30 years ago, you would have used very simple regression models where like many of these things would just be, point estimates that you'd add up and that would get you your final prediction. And then you'd use that to make your decision. And so like, to what extent can you really understand what they're learning about? So we've invested quite a lot in interpretability and explainability over the years, and many of those techniques. I find that field a little bit adrift at the moment scientifically, but but there's still a lot of work to be done there.
So you don't believe in SAE is right?
I feel like, I think they're very interesting tools. Whenever we build any kind of secondary explainability or interpretability tool, you create another validation problem, which is how do we know that the tool is good? And then you create another secondary, tertiary validation problem, which is like, how do we know the tool that we created to validate the tool is good? And then it ends up becoming this like turtles all the way down problem where you don't actually know if you trust anything. And we went through this with, explainability techniques, things like SHAP, and then other, the myriad of other explainability techniques that were developed, a decade ago. We're going through this with SAEs now. It's just like at the end of the day, you either trust it or you don't. And then the same thing is true of like language models where, they'll produce this reasoning trace, and that gives you some like, oh, okay, I understand why this model came to this decision or why it took this action or whatever. And it gives you this feeling. And then someone comes along and does a piece of research that shows you that like the reasoning traces have nothing to do with the final thing that the model does. And then someone comes along with another study that says, well, the way that you figured that out doesn't actually tell you if the reasoning trace had anything to do with what the model finally did. And you just do this like recursive loop where someone once described it to me as roller skating on marbles. It's like
But from your perspective, though, so how you like kind of balance it, or how you even measure it? Like, do you think like so there is you want to make sure that like the worst case scenario, right? It like there will there will not related to the decision will not be related to these features, or like in probability this feature is the most important one, or like I don't know, best case scenario, um what are the factors that you are taking into account when you are thinking about explainability?
Yeah, I mean, this is what I fundamentally find like unsatisfying about explainability. I think what people want when they talk about explainability is some causality, but they're trying to get their non-causal model to tell them something causal, right? Like I think that's what they want. They want to know that like these two things in the data caused this other thing that I cared about, right? And that's not what the explainability techniques tell you, and that's not what the models are capable of providing. But that's the guarantee that you want. And so at the end of the day, like what people are asking is, I think that these are, let's take the lending decisions. Like I think these are legitimate reasons why I shouldn't give somebody a loan.
In general, like what types of problems, like is it like supervised problems, that are there like unsupervised problems, like what kind of like pipelines do you have that you're trying to solve?
I mean, it's all the different kinds of problems. You know, within Capital One, we have you know, a range of different areas where we're working with AI systems. You know, the one that people are probably most familiar with is fraud. Um, we have to that is tends to be a supervised problem. Um, Although what we found very useful, because fraud tends to be very rare, you know, within the broader set of either like the number of transactions you have or the number of customers you have, you know, you're always going to have some percentage that are fraudulent. And so there we've, you know, because the events themselves and are pretty rare, we find that self-supervised learning is like very, very helpful as like a pre-training step that you can then use your models after the fact to learn um, these class imbalance problems, as you know.
Yeah, for I just yeah for each episode, like we have 5 minutes that we must talk about JEPA model. So yeah, this is this is the time. Um, and do you think like is it helpful, Anto, to use what people call foundation models, or do you think they are like just there are like different problems, and even though like everything is about money, they are fundamental different? Or do you think like, yeah, at the end we just want to aggregate everything and we want to use all the information that we can, and then we just I don't know, train ahead for each subtask or
Yeah.
And
different task?
and a quick related question. It seemed like for a long time that time series type problems and problems specifically in this domain were very resistant to transformers and neural networks being better than baseline methods, ARIMA, probably a lot of other methods that you might know the name of like that were kind of old school. Would you agree with that assessment?
Yes, I mean, up until very recently, the baseline methods in time series were still quite strong compared to deep learning. I think that that Rubicon has been crossed. I think there's been a lot of great work in time series foundation models. You know, there's 3 or 4 that are like really, really strong. Some that I think is quite interesting, both in like the tabular domain as well as in the time series domain, which is kind of related but not exactly the same, where, you know, some, if not all of the model's data is purely synthetic. And they're finding that you can train these foundation models on entirely synthetic data and then use them for real world tasks to great efficacy. So there's, you know, the work on TabPFN and many of the follow-on efforts on TabPFN, as well as I think I could be wrong, but it's Chronos 2 out of Amazon. I think much of that was trained on synthetic time series data and then validated on real world data. And so I think that's like a really interesting question. I mean, if that's true, we always have this kind of uh, uh, mantra that we tell ourselves that like the real world data is so unique, and there's no alternative for the real world data, and that it's impossible to it's so complex that it's impossible to like create synthetic data that would at all teach you anything about the real world data. But then you start to see these examples where models are able to be like pre-trained on purely synthetic data and then perform well on real data, and it tells you, well, maybe that mantra is incorrect. Maybe like either it's not so complex, or that we've gotten really good at generating synthetic data that looks like real data. I suspect that we haven't gotten that much better at generating synthetic data. I mean, maybe we have, but I suspect that the reality is that the data that we think, the real world data that we think is really complex, is actually like living on a fairly simple manifold, and we just have to like develop synthetic data techniques that can find that simple manifold and generate data from it.
Do you think it's like related to the fact that like it is time series data, right? That like at the end you just need to learn connections over time, or like one of the, let's say, the most important thing is to learn that you have 2 points and they connected because they are on different time. So you can use much different types of data, right? And just to learn this point.
That's right. Yeah, I mean, that time series, as you mentioned, Alan, like the best time series models, even up until a few years ago, were exponential moving average models, right? And like at the end of the day, what they were fitting was like only a few things: the shape, level, and the seasonality, right? So it was like the y-intercept, the trend, and the seasonality. Like there was just 3 components to those models. And so like if that's all you needed to get a very strong baseline, then like how hard is it to create data that looks like that? And then if you can do that, then you can train a model with a bunch of synthetic examples of time series. So yes, I think that's absolutely true. Um, that is we use synthetic data in like a lot of different ways. I mean, there's a lot of synthetic data out there in the LLM space that's, it's not truly synthetic in that you're sampling from you're rephrasing something, or you're sampling from like a larger model for your model. And so you're essentially using quote unquote synthetic data to distill the larger model into data that you use to train your model. But in this case, it's purely synthetic. And so I think that's a really interesting paradigm. And like, I wonder if you couldn't possibly, well, maybe you could, I could eat my words here, but like, could you possibly train a language model with purely synthetic like byte streams, as opposed to purely synthetic language, like actual just byte streams? And then could that be any good?
Oh my gosh, that might get rid of tokenization. That's the real holy grail.
Yeah.
But do you think that, so I'm not sure that I understand, like in the bottom line, like, do you think like foundation model is the way to go? Or do you think like we should train separate small models for each problem?
I think about, so there's 2 questions. One, is the foundation model the way to go? And 2 is using a foundation model that's pre-trained on web text the way to go. I definitely think across all the different domains of what you might do in consumer finance, you could have a singular model, because at the end of the day, the sources of information that model is, those different kind of decisions you're trying to make, they all rely on the same sources of information. So there's no reason why you couldn't have a singular model. Now, could you use a model that's pre-trained on web text to answer the question, is this person committing fraud? Or should I, give this person a loan? I don't know if I would. We haven't seen compelling evidence. We've obviously experimented with that. We haven't seen any compelling evidence that they're good, even up to including doing fine tuning and continuous pre-training on the data that we have for the tasks we have. They're fine, but they don't outperform the things that we're able to build from scratch. And there's a couple of reasons why. I mean, there's some key bottlenecks. One is that in order to use the language models, you then have to like convert all of this financial data into language for it to like have the semantic structure that the model can at all benefit from. And you can imagine like taking 5,000 credit card transactions, putting them in a row or putting them in a sequence, and then adding all the like commentary from in a language perspective and then feeding that into a language model. It's like a huge waste of context window. And so I think like at the end of the day, what we'll probably have is encoder of that kind of thing, like a separate standalone encoder that's just like pre-trained to understand those kinds of inputs. And then you can do Lava style training where you like jointly train that with a language model if you want to do language model style reasoning. Or you can use that encoder in the way you'd use a vision encoder.
I'm sure that you showed that you saw that there was I don't remember the name of the paper that they put tabular data to regular LLMs and ask them to classify it, like time series data,
Yeah.
and then they insert the same data but to VLM, and they insert it with graph, like the actual graph, the actual figure, with axis and things like that, and it got much better. And
Yes.
they show that like if you put, I don't know, the units in the axis, it make it better, or like a lot of weird thing like that. And it makes sense, right? Because then you can use prior knowledge, like to change the embedding or the way that you
That's
feed
right.
to extract the relevant information.
Right. Yeah, I mean, there's nothing that like is inherently intuitive in a number stream. If you're modeling semantics, a number stream doesn't tell you very much. That's why like humans aren't very good at looking at numbers in an ordered list and being like, oh, okay, that's what I should do with that. So we build models, or we build visuals, or we do other things with the number stream to then use it to like make decisions or take actions, etc. Because in and of itself, it doesn't carry any semantic information.
Yeah. And also, so there are two separate questions, right? One is if you can use transformers or like recent advantage in the architecture and I don't know, the learning algorithm in order to make better models. And the second one, if we can use LLMs in order to understand some parts of the data that related to language, right? In order to use it in our models, right? And they're not the same question because you have different types of data.
That's right. That's right. And I think we're doing both, and we're finding that that's like that is a very helpful. Um, that is a very helpful approach. The big question that I have that um, this gets to the framework that I presented, where like you need to understand the data. You need to have a model that can take it in effectively and use it. So like I don't think LLMs are like the best way to ingest tabular or time series data. I think you're better off building a standalone encoder, whether that's you're treating that as a foundation model or not. But then there's the decision and action that you take given that input information. And this is where like I'm not sure. I just to state my own like uh open-endedness here. I think there's a tremendous power of reasoning in language, that if you do your reasoning in language, it's both, despite what I said earlier, it's somewhat transparent, right? Like you can introspect it, but it also, is shapeable to make sure that it's like following some causal chain that you believe is a good causal chain. And so then it becomes, can you take as input these complex financial data sets, but then do the reasoning about them in language and then arrive at an action space at the end of that reasoning. Like that, I think, is a very compelling approach to financial decision making. But that might not be the optimal approach. You might also want to do your reasoning in latent space. Like, we've seen this be true in a few places where like doing your action design in latents could be more efficient, could be, also just more optimal than putting everything back into token space at the end and then hoping that it gets there eventually. So I'm not exactly sure where we're going to land on that front, but I think that's the next phase of this journey is like, how do we do the reasoning to get to the like final actions that we want to take?
It's a great question because I think even in language, right, there was the coconut paper, right, that basically make like a continuous chain of thought, right, in the embedding space.
Right.
And then like they had like really nice experiments, but they didn't success to scale it out. And you can't use it with larger models, and also like I don't know the recurrent layer models and things like that, right? It's the same idea, but there is something. It looked like there is something in language that gives you much better results, and it's much easier to scale it up.
Yes, it
So
could.
so I think it's very interesting. Like, I think this
Is
is
it
something in
inherently
the
easier to scale it up, or is it easier to scale it up because we've just built the like technology to scale it up? Is there something about language that's easier to scale? I don't think
so
that's true.
so I don't know, my suggestion, or like my I think that it's not that like inherently, like it's inherent in the sense that it gives you much more regularization, better regularization, because you restrict yourself to tokens, to well-defined specific tokens that you can go and like represent everything that you want, right? When you go to embedding space, you can represent everything. And then you need, most of the time, you need explicit regularization in order to prevent from just, out of distribution
Yeah.
tokens or things like that. But here you have very specific set of tokens, and you probably saw them. There is no read out of distribution. It's much easier to control them. But someone needs to make this more rigorous and make the actual experiments
Yeah.
to
I
show
could
it.
actually I could make an argument for a hybrid system where you're partially reasoning in latent space and partially reasoning in token space. I think that's actually how like most biological cognition or human cognition happens, which is that like a lot of it is just passive thinking that's not in language, and then some of it every like periodically you get like a little blip in a sentence that like pops out, and then it goes back into this latent recurrence.
Yeah, and well, I'm still wondering. I mean, my thought can be wrong both if I internally vocalize it and if I don't. And so I worry that by reasoning in the latent space where we've improved things a little bit, but I just do not see this as the panacea for hallucination.
But then, so okay, let me put it in a different context. Would you, if you were riding around in an autonomous vehicle, I'm not going to say which, and you found out that the autonomous vehicle was translating all of its images into language and then making a decision about what actions to take on the road in language space, would you feel more safe in that car? Or would you feel less safe in that car?
Right at this moment, I've seen enough of the like the issues with image recognition models, even the ones that try to describe complicated scenes. So I suppose a lot less, right? I suppose that's the justification, right? For
Yeah. I mean, I think some things are like inherently better in latent space. Uh, that's why I think like having a system that could do both is probably somewhat optimal. Yeah, like even yourself, if you're driving down the street, you're not thinking to yourself, well, now I'm going to turn the wheel, 10 degrees to the left, right? Like a lot of the actions and decision making you're making is very implied and implicit. It's only like higher order cognition, your philosophical thinking or your argumentation. It's like those things happen, and even inside your internal monologue, those things are happening in like language space. But most of your thinking, I don't know what percentage, but I would say uh, a very high percentage of your cognition is not happening in that level of space. It would be very exhausting to have an internal monologue that was telling your left foot to move in a particular way.
That's true. I'm just not sure that, I think I said it before. I'm not sure that like you need, or like we as society needs to replicate how human behaves, right?
No,
Like even to get good models, it's not clear that the right path is to mimic humans.
agreed. Even if you set that aside, the mimicking humans, do you still think that like every action should be determined in a language space? Is language the optimal representation of the world?
I think it's not the optimal representation, but it's quite good representation of the world. It's like humans, at least for problems that we actually care about them,
Okay.
you know, that humans care about. I think language is very good way to communicate and to think about these problems. I think this is why like LLMs are so good. To take physical models and to take physical signals, for example, it's much harder. It's much harder because you have so much information, and you have so much factors that you need to take into account. So probably you need much better models in some sense, like bigger, larger amount of data.
I would challenge you on the point for problems we care about. I think there's a circular logic there, which is that we care about problems that we can solve with the technology that we have.
That's
Uh,
true.
and so we
I
found a
agree.
lot of problems that we care about because the tools that we've built can solve those problems.
That's true. No, I agree.
Well, I would even argue back just a little bit. There are a lot of concerns and problems we have that we have no hope of approaching with current technology, or getting a falsifiable answer on. But uh, I mean, I'll just point religion being the most obvious one in my mind.
Yeah. Well, I think the point I was trying to make was that, you know, uh, we are very interested right now in the kinds of problems that language models can solve because we have invented language models that can solve many problems. And so there's somewhat of a, a circular approach to, like, we go out and say, okay, we have this thing, let's go and see. And so, a lot of the emphasis on coding systems that we talked about at the beginning, like, it is good at coding, and therefore now we're solving a bunch of problems, and we seem to care about coding problems. But does that mean that, like, prior to this moment we cared about coding problems more than cancer treatment? No. It's just
Yeah.
that, like, right now we're like, this is a very good technology for coding.
I think this is Jevons paradox, and I also want to quickly go back on the optimal. Language optimal? I'm influenced by, I think it was a guy named J.G. Ballard, or I forget their name, who has demos on, or Ballad, something like that, who has, I think, written some papers, and they had some demos of like GPT-2 lossless text compression,
Uh-huh.
where you could put any text, run it through, and you can do this with most LLMs. And what's interesting is to look at the produced compressed representations. Often those compressed representations were made up of Chinese. And that also tracks with what my friends who speak and write Chinese tell me, is that I've had one describe English as linear, and Chinese and languages like it as quadratic, in terms of how much uh, diversity you can get out of ideas from so few characters. Like, the per character information conveyed is so much higher
In
in the maximum, right?
Yes.
With languages like that. So I'm
But
But this
fascinated.
is
that's
related to
the trade-off.
tokens, right?
Yes,
Yeah, that's
yes.
the trade-off between vocabulary size and
Yeah.
Yeah, yeah, and I'll also point out that occasionally we've seen this behavior during like reasoning chain of thought, that kind of thing, especially with DeepSeek models, where it'll like switch in between English and Chinese
Yeah.
midway through, right? So I'm wondering if Chinese is a slightly superior language from a information theoretic standpoint.
I mean, one of the
I think
functions of language is to convey internal states between people, right? Like, we have this problem where we have independent internal states. Something's going on in Ravid's head right now that I can't see. Alan, you've got something going on. You've got some set of beliefs, opinions, whatever. And we've created this technology to coordinate and to share what's going on in terms of our internal state. And it is a good representation of that. And so it's a good representation not of the world, but of what I see. It's a good representation of what Ravid sees, a good representation of what Alan sees, it's a good representation of our shared understanding of the world. But it's not necessarily the optimal representation of the world. It's an optimal representation of our collective understanding of the world, or the human vantage point.
Yeah. So actually, there is a great work of Nogla Zelensky. She was a Kali student, and she looked on different language, and she saw that there is like a part optimal curve that all the language, if you look on the compression of the language versus how much information they are carrying, there is some, like, all the languages are on this optimal line that balance between this efficiency versus expressivity. I want
Oh,
to
okay. Yeah, that's interesting.
I want to go back to you talked about, like, how to detect that someone specific making a decision. So I want to go back and to ask you about personalization. You can say in general or specific on your task, but how you think about personalization? Do you think there is it's something that, like, we need to address specifically, or like you just give me all the data and the model is expressive enough that make you to a specific, like, it will work even for a specific person?
Uh, I mean, you'll always have incomplete information, and never if I had to tell you first, before you're going to get a good personalized system, that you had to tell me every single detail, everything about your life, every childhood experience you had, all of the thing, you would spend so much time giving me information that it would be annoying for you to use this system. And so unless we've like tagged every person with everything that they've ever done, you're never going to have all the information you need to make a good personalized recommendation. You
I
can
will ask. I will ask just a second. I will ask even something stronger. Do you think that even if I have, or even if you have all the information, do you think you can get a perfect decision? If you have the, like, I don't know, all the history.
everything about you that you've ever done.
Yeah.
I don't think it'll be perfect because, well, for one, people are random. Uh, not as random as we'd like to think, but we're still random.
Free
um,
will and all these things.
yeah, free will is definitely a thing. But the world is also evolving around us. And so, I could know everything about you. And what I wouldn't know is that, like, this morning you saw a friend who was wearing something that you liked, and that thing just got released like 2 days ago. Maybe if I had perfect information up to the real time moment, maybe I could get close. Um, but it would be exponentially difficult to get all of that. So I don't think that's possible, but I think we can get very close because as random as we are, we're not that random. And we share a lot of commonalities with others. And this is where, learning not just from individuals, but from collections of people and who you interact with and what people like you tend to do is very powerful. And that's like at the core of like most recommender systems is basically trying to figure out like, what do I know about other people who look very similar to you, and what can I use from that information to determine what to personalize, whether it's content or recommendations or otherwise. I think there's maybe a more interesting question, which is that, and this was getting to this point on wanting a person on the other side of something. It is because you know that, or at least you hope that the thing that you're reading is unique and grounded in experience. If there was a way that I could guarantee that the AI that you are interacting with is unique and grounded in a very specific set of experiences that you get to control, would you prefer that system over a generic system that's learning from everybody? Um, and then it becomes, do you not have AGI? Do you have like something very specific to you? And is that more either engaging or more preferential, or is that itself more personalized because you get to select, like, I prefer to interact with this one because of its experiences? And then does it very quickly look like a robot race of artificial humans?
But I feel that the problem is that, like, you have different types of let's say data that you actually need to combine together, right? Like, you have data, general data about, I don't know, decisions that other people made that are similar to the current decision. Then you have the previous data points of this person, right? That it's different. Like, you don't have the next point, right? Um, and third, you have just other let's say current states of the world, right? Like, what people are doing right now. I know what is the economy situation right now, or news, or things like that. And somehow you need to I don't know, to balance, so to weigh them, and it's not even clear what is the optimal thing to do here, right? Because you need all of them, but it's not clear who is more important. So from your perspective, who is more important?
No, I think that's absolutely right. And I think especially where it comes in financial services, where it comes in, and this is really critical. So a lot of the decisions and actions we take have a very long time horizon. When you're answering a question, when you're doing a math problem, even when you're making a recommendation, the time between the input and the thing you're trying to model is either zero or it's very small, right? Answering a math question, the time is zero, right? Like, it's contemporaneous. Answering a PhD question is contemporaneous. But like, even predicting what somebody's going to click on when they log into their when the Instagram or something like that. That's a fairly short range prediction. If you make somebody a loan for a mortgage, for instance, it's not something we do, but say you're giving someone a mortgage, it's 30 years. You have to say, like, will this person be able to pay? That's 30 years. You know, then things change over 30 years. How many like financial crises there are? How many this person might get divorced, they might get remarried, they might have more kids. Like the world is going to be fundamentally different in 30 years than you could possibly imagine right now. And so you're making a decision that you have to live with for a very long time. And so, there's a lot of uncertainty, and you can manage that uncertainty in a variety of different ways. And the other piece to it that I think is really critical, that humans have gotten really good at, somewhat good at, finance over the last few hundred years, is imagining alternative worlds. What would happen under this scenario? What would happen under this scenario? If this goes wrong, what will happen? Kind of being professional worriers is like a lot of what banking boils down to. And you could get an AI system to do all of that worrying, but you would have to be able to prompt it with all of your hypothetical situations that you would want it to play out. It would have to be able to then play them out in a realistic way, meaning that it would have to like uh, really be able to imagine what an economic crisis would look like, or really be able to imagine what interest rates going up or down how that would play out in the economy. And so that gets into having an AI system that can act as like a financial world model that can essentially model the transition dynamics of if interest rates go up by this amount, this is what's going to happen with everything else, and then this is how that's going to play down to like consumer spending and inflation and all of that stuff. I think it's a little bit in vogue right now to talk about world models. So like, I don't think that's like gonna be the thing that solves it, but I definitely think that's a direction to head in within financial services.
In any good world model, right, the most important part is the uncertainty. What's your thought about uncertainty? How you kind of take it into account? You're more conservative because you're a bank. You're like you have different stages. How you think about it?
I think, I mean, yeah, go ahead.
Oh, I was just going to add to that. And specifically, what techniques do you use for model calibration, which is, I think, what they normally call the attempts to model uncertainty?
There's been a lot of work on modeling uncertainty in deep learning, things like Monte Carlo dropout and deep ensembles, where you're essentially trying to like sample from some space of possible models that could be fit to the data. And then use that to get a distribution of overall possible predictions, and then that distribution provides you with your uncertainty estimate. And I think that's a very specific type of uncertainty, and it's an important type of uncertainty, right? Which is that, given the data that I have and the models that I could fit to this data, what is my confidence that I have the right model and the right prediction? There's maybe a more important type of uncertainty that comes outside of the model itself, which is, what is my confidence that I know everything that I need to know? What is the confidence that I have the data that I need, that the world's going to look the same? Those are things that kind of live in idea land and in like the humans that are running the systems that say, oh, actually, I think that the economy is going to go up or down in the next year, and therefore I should not trust my models that are telling me that everything is going to be rosy, right? Like those are the kinds of things. I actually think that kind of thing, that kind of research based, let me just read a bunch of articles on the internet and formulate an opinion about where the world's going. This gets to like prediction markets and things like that. I actually think AI is going to be particularly language models, going to be very good at doing that kind of thing. We're already seeing it being very useful in like equities research, at least as an assistive technology to people. It can go and find all of the things that you ask it to find and summarize them and give you its take on like where the world is going. I think that's probably a very good application of it.
By the way, what do you think about prediction markets? Like I don't know. I see recently a lot of okay, so there are several questions here. One, what I wanted to say is that like all the inside information, right? Like there are some people that track, inside information that like people now they put I don't know 10,000 on very rare event, very esoteric event that suddenly happened 2 hours later, right? And it's crazy that basically it's legal, right? Like there
Yes.
is no something that prevents you from doing it, right? If there is like an Israeli attack on Iran that I just saw it on Twitter that someone like put in the last Israeli attack on Iran, he put like I think $30,000.
Yeah.
And 2 days after it, there was an attack, and he earned 400K.
Didn't somebody bet a lot? There were some questions about insider betting on Taylor Swift's engagement, I think.
Well, and insider betting on Maduro going down too.
Okay.
Yeah.
Yeah.
Yeah, it's the same thing, right? People have information and they are using it, and some people say that actually it's not it's legal, and actually it's good because it helps the information flow more efficiently, right? Like the idea is to help these people to share this information.
I see.
Um,
Because it
but
induces information sharing. Yeah,
yeah,
that could
to
be
make the market more efficient.
the market for
Uh,
information, which is a weird market. Um,
yeah. But what? So, but the other thing that I want to ask you about is models or like LLM for prediction. So, do you think this is something that uh, it will be? We see more and more works about it. So it started with stock prediction, and now we see this event prediction. Do you think that this is something that is um I don't know, useful, or like do you think we will see more and more models that are using this ability in order to make, I don't know, financial decisions or things like that?
uh, oh, every single paper that I've read on stock prediction has been uh, poor quality from a scientific standpoint. So, like, I don't think that I've seen any compelling evidence that, like, from a purely should I buy or not buy this given stock perspective, I think I don't trust them, or I don't trust the studies, and maybe the LLMs will get there. Um, like I said, I think a lot of what goes into those types of financial decisions is the type of research. Studying the financial statements of a company, building models, understanding the economics of how that company operates and the broader market that it operates within. All of those discrete tasks, I think, you know OpenAI could build either one system or like a collection of systems that could like decompose that into a workflow and do a really good job at providing you with kind of equity research, for instance. um, Prediction markets are interesting in that I think where the prediction is based on, again, broad research that's publicly available information, and it's really just about like distilling as many sources of information and then like having a good formulation of what the prediction is. I think they'll be very good at that. Where, you think about like sports betting, a lot of it's like who has the angle on inside information, not necessarily public information or semi-public information. I mean, was the LLM going to go like build a relationship with like a bunch of players and like, go to the club with them so that they can get like information on who's feeling sick when? Like that's what the sports books do. Like LLMs aren't capable of operating in that world, and so like no, they're not going to be good at that. They can only go off of the ESPN headlines that they read, and so this is where I think the limitations of it being like squarely stuck inside of a digital reality will like always preference the humans.
But do you think so, Andov, to get a loan or something like that? Do you think it will be helpful to have specific models that first will predict some, I don't know, events of the world? For example, like if you see some economical crisis in the next 10 years, right? So we can first predict this, right, and then feed it to our model to calculate the chances of the that we will
Yeah,
not.
I think
return
it'll
the law.
look somewhat like a multi-agent system. You'll have like an agent that's like specific to macroeconomics. And you'll have like an agent that's specific to, estimating some specific element of risk, and you might have some agent that's specialized in valuation or determining like what the lifetime value of something is. And those agents will then like be brought together by some orchestrator that says, okay, overall, based on these factors, this is what I think we should do. That I think is where we'll get to eventually, and that might be in the same way that we call multi-agent, like we make them sound like they're their own unique thing. That might just be like calls to the same model, um, in a variety of formats. But you would want to, I think you would want to separate out those different predictions, if for nothing else, then so that you can observe how those types of predictions interact with each other.
Yeah, and I mean, I think models are really models with sets of settings associated with the prompt being one component, then the sampling settings another component, and so treating those as different agents is often how multi-agent frameworks actually frame it. And it's probably the right way to do it because I do think bigger models are better than smaller models.
Yeah, for sure.
Okay, I think we almost out of time. Do you have anything else that you want to add to promote something? Like to have a discount about new credit cards, whatever.
No, I mean, I think this was really fun. Thank you so much for having me. It was great to chat with you. Within Capital One, our team's called AI Foundations. It's you may not have heard about it if you're an AI researcher, but we are growing. And so if you're interested in coming to work on some of these problems that I described, you should check it out.
Yeah, I strongly support it. I work with Bayan, and he's great. You should come to work with him. Okay, Ellen, do you have anything else that you want to add?
No, it's been a great episode as always.
Thank you.
Okay, so thank you so much.
Take care.
Bye. See you next time.